And that's really the point. The point is to develop technology so that the speed of production is quicker, so that you're able to combat and reduce and control the spread of an infection. There's also potential for the use of messenger RNA technology in combating cancer. And while my goal today is not to convince you to take or not take a vaccine, that is a personal decision. Transparently, the large majority of unalivings, the large majority of serious complications, hospitalizations, ICU admissions were people who were not vaccinated. So it's important to be able to have the funding to really assess whether or not this is a true causation. So defunding the science, the research and development of this particular technology has extreme consequences. How important is messenger RNA technology? mRNA technology has great potential beyond its use in vaccine development. With the unfortunate loss of life in Atlanta, in which it is believed as of now that the suspect allegedly targeted the CDC, highlights the importance of dispelling mis and disinformation and addressing areas of concern for the public. Today, we are fact-checking and myth-busting information regarding messenger RNA technology and its capabilities.
Really, my story was more about controversy. It was about how my mom was bad and I was good and I was ripping her a new one. Not true. My mom, she was misinformed and misled by sources that convinced her that if she was a loving parent, she wouldn't vaccinate. My mom got a lot of her beliefs from social media, from Facebook, and from organizations that were allowing their platforms to push lies that were very dangerous. You need to make a personal decision for yourself to say, this is accurate, this is what's real, and these lies are not okay.
And as always, we thank you guys for watching, and don't forget to do what? Click subscribe. Hey, you guys, your girl is back for another one. So as you guys may have been paying attention to the news lately, there has definitely been a controversial announcement from HHS. And granted, this is not the first time that announcement coming out of the HHS recently has caused us to clutch our pearls.
Do you wear an Apple Watch, a Fitbit, an Oura Ring? You know those are tracking devices, right? What? How else am I going to make sure I'm getting my 10,000 steps? RFK Jr. says he wants every American to wear a health tracker.
My vision is that every American is wearing a wearable within 4 years.
Not because it's cute, not because it's trendy, but because it's part of a bigger plan to optimize the nation's health. Let's talk about what that really means.
Holy cow, folks, I told you this was likely going to happen, but according to Wall Street Journal, sources familiar with the matter are reporting that RFK Jr. is going to oust the entire 16-person panel of the U.S. Preventive Services Task Force, or USPSTF. According to people familiar with the situation, he is doing this because he believes that their views are too woke and that this is really problematic. And this all stems from the fact that there was a recent Supreme Court ruling that was Kennedy versus Braidwood Management Incorporated that gave additional powers to the Secretary of Health and Human Services to change the committee members of the USPSTF without congressional oversight. This is an important group of individuals who make recommendations that are called A or B recommendations for various public health measures such as cancer screenings, HIV testing, etc. So if those recommendations are taken out, then insurance companies are not required by law to cover these screenings, which are vital to the health of people in this country.
But today we're going to do a little bit of a time capsule, run it back to the pandemic, where we're going to do a little bit of fact checking when it comes to messenger RNA. Now, before we get into the DNA of it all, you like that? We're going to ask you guys to please, 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 if you haven't done it already, hit the like button, hit the subscribe button. And even if you're just hopping in for a quick moment, that's okay. We're going to provide the chapters so that you can go directly to the questions you want answered. But in order to get this information out to more people so that they hear the facts versus myth, we're going to need your participation, and we thank you guys for doing so. So let's get into it. So today, I'm literally just going to touch on what is fact, what is myth, and hopefully dispel some of the myths when it comes to messenger RNA. Now, granted, messaging coming out of RFK Jr. has caused many to be concerned for a variety of reasons.
After reviewing the science and consulting top experts at NIH and FDA, HHS has determined that mRNA technology poses more risks than benefits for these respiratory viruses.
Health experts say this is not true. And mRNA, the type that protects you from diseases like the flu or COVID-19, have saved millions of lives.
The evidence from the COVID-19 pandemic is overwhelmingly that the benefits outweigh the risks by a very large margin.
And unfortunately, when it comes to platforms that are myth spelling, truth busting like we do, sometimes we risk being. So this is why we really need your help to make sure that that doesn't happen by participating with a comment, like, or share. So the latest announcement has gotten us very concerned, and in the medical community has caused us to raise an eyebrow or two, because the information is not backed by science. And while my goal today is not to convince you to take or not take a vaccine, that is a personal decision. Which is very different from health policy. So an individual's decision, if there is enough individuals making the same decision, can ultimately affect public health. But when a public health policy is made, it's looking at the broader scope of the intervention versus the potential pathogen. And the goals include minimizing the spread of the pathogen and minimizing serious complications related to the pathogen, right? So we know, for example, the common cold is a pathogen. But for the most part, most of us do pretty well with combating the common cold, which have multiple variants on an annual basis, on a seasonal basis. However, other viruses and bacteria can cause much more serious outcomes. And so the goal is to minimize those serious outcomes, which includes, of course, unaliving and hospitalizations or long-term sequelae like respiratory damage or respiratory problems, long-term cardiac problems, long-term neurological problems. Those are sort of the big outcomes that we're trying often to minimize and, if at all, abolish. So I'm going to go through the top things you should know when it comes to messenger RNA technology, not just vaccine. Though the primary use of messenger RNA technology has been focused on vaccine, it is not solely used for vaccine production. So let's get into the top things you should know. So the first thing that I've noticed in terms of commentary on the social and the media is the fact that people still have the belief that messenger RNA vaccines somehow are not quite a cure, but this panacea, like it's 100% preventative, and that's not true. The messenger RNA vaccine is not 100% preventative. Its goal during the pandemic, internationally, not just locally or nationally, but internationally, the goal was to minimize serious outcomes, hospitalizations, especially ICU admissions, and unaliving. That was the primary goal, which it did effectively. It was not intended to be, nor was it assumed or presumed to be, a solution to completely preventing every individual from getting sick. So it is possible to get the vaccine and still be exposed to a variation of the virus that can make you ill. But guess what? Because you had the vaccine, you were more likely to be able to handle those variations, as your immune system had some ability to fight back. Whereas the largest number of those who became seriously ill after the implementation of the vaccine were those who were not vaccinated. And that's really important to continue to share with people transparently. The large majority of unalivings, the large majority of serious complications, hospitalizations, ICU admissions were people who were not vaccinated. Even though you may accomplish a herd immunity with one particular variant because sufficient people became vaccinated against that variant, as the virus mutates, you're less likely to be able to adequately protect those who couldn't get vaccinated because of underlying medical conditions or potential allergies versus those who decided and opted not to be vaccinated. That's really important to know. So now that we've gotten that clear, now let's get into the messaging of it all. So another interesting commentary, I would say, is the thought that somehow the messenger RNA vaccines are causing mutations of viruses.
RFK Jr. also says that these vaccines don't perform well because if a virus mutates, it becomes ineffective. But experts say this is misleading. Vaccines can still offer some protection even as a virus mutates.
What you need to do is to vaccinate against the current variant and make new vaccines against new variants as they emerge.
Now, let's just say that has not been scientifically proven to my understanding. And I'm going to share with you what are the top ways in which viruses tend to mutate. Let's talk about it. The first thing you should know is the fact that the more people who become infected, the more likely you will end up with variants of a particular virus. And so viruses themselves aren't living things. They require a host body or a host cell in order to be able to replicate and ultimately spread. The rate of viral mutation is really dependent on how infectious the virus is and how virulent the virus is. The more virulent the virus is, the more likely it will infect more individuals and the faster it will spread and ultimately mutate. Now, let's talk about what some of these terminologies actually mean. So when we talk about mutation, we're talking about when the virus actually replicates and the end product has some type of difference either in the DNA or RNA of the virus, and these differences are then considered to be mutations. When we talk about a viral variant, we're talking about over time, if there's enough accumulation of mutations, then a variant will emerge. A new strain is when we have identified a variant that has new biological abilities, and that's what is considered to be a new strain. You hear this seasonally when we talk about the flu virus or influenza virus specifically, when there is a dominant strain that is identified and has some type of larger biological impact. And then the vaccine is directed against that particular dominant strain.
RFK Jr. also says that these vaccines don't perform well because if a virus mutates, it becomes ineffective. But experts say this is misleading. Vaccines can still offer some protection even as a virus mutates.
What you need to do is to vaccinate against the current variant and make new vaccines against new variants as they emerge.
Now, let's talk about ways in which viruses mutate. It is not known scientifically that viruses mutate as a result of the vaccine. And I will say that that commentary is in some ways causes individuals to think of things in a way that is not exactly truthful. And what I mean by that is the fact that it's quite the opposite. If you have an effective vaccine in general, regardless of whether it's a traditional method or whether it's an mRNA technology, and I'll explain a little bit more about the differences in a few moments. The ultimate goal of the vaccine is to decrease the rapid spread of the virus or the bacteria, depending on what the vaccine is targeting. Now, the more you are able to do that effectively, then you make it harder for viruses to mutate, because we know that viruses mutate by either replication error is one way that they mutate. They mutate also as they interact with our bodies and they interact with our biologies and our proteins, they can develop a new mutation. They also mutate as a result of recombinance. So what that means is if two viruses enter a cell at the same time, the way they interact with that cell may emerge a new mutation. They also mutate as a result of natural selection. So the more virulent a virus is, the more likely it is to be able to stick around and mutate. They also mutate as a result of environmental factors. We know the effect of ultraviolet rays can cause DNA and RNA damage. And so that can then lead to another mutation in a virus. Now that we've gotten clear how viruses actually mutate and that the goal of vaccines is actually to prevent not just illness, but indirectly the mutation of viruses by minimizing the spread of an illness. Now let's talk about what are the differences between the two types of technology? So in the past, we have used more traditional ways of coming up with vaccines. And the messenger RNA technology has really been very beneficial in a variety of ways. So let's talk about just some of those common. Tradition doesn't always mean better. And ultimately, our goal is always to improve our technology so that we're better able to combat seasonal infections and ultimately a pandemic. I saw this diagram that really broke down the differences between traditional and mRNA technology that I thought was really cool from Vanderbilt University. So I'm going to utilize it to help explain visually some of the key differences between the two methods. So in the past, what scientists ultimately did was that they would take a virus, attenuate it or make it inactive, and then grow that virus or bacteria, depending on what the vaccine is. And then once the culture is made, then inject that attenuated or inactive virus or bacteria into the individual that will then stimulate the immune system to produce antibodies against the attenuated or inactive pathogen. Now, messenger RNA kind of was a game changer, just simply because, and by the way, it's not new technology. I'm going to talk about that in a few moments, but because the science was already there, scientists already knew that it is quicker, especially when you're faced with a pandemic, to be able to produce vaccines based off of a DNA template. And so the messenger RNA would instruct the human body to produce a particular protein, and the protein that would be targeted would be a protein found on the surface of the virus. And that instructs the body to create the protein. So again, this targeted protein would be the spike protein. The messenger RNA instructs the body to produce this protein, right? Now, what that ultimately means is that the cost of production was cheaper because you're not having to grow or culture a virus over time. So culturing viruses is a very labor intensive process. And certainly as a result of the labor intensive nature of that process, it is also a very costly process and can take sometimes months and years because of the variability and the inconsistency when you are culturing something that has the ability to mutate. Kind of makes sense, right? And so the production of the messenger RNA vaccines are much quicker because you're just using a particular DNA template to produce a protein. So it's a much quicker and much more consistent process. And so people were concerned about just how quick or how warp speed the process was, but it's just because of the technology. It's just a different technology that leads to it. They weren't taking any shortcuts. There was no shortcuts to be taken. And so that's really important for people to know because a lot of conspiracy came out of just the speed of production. And that's really the point. The point is to develop technology so that the speed of production is quicker, so that you're able to combat and reduce and control the spread of an infection, especially one that leads to severe outcomes. That is the point. And if we're not open to technology doing that, then we really are not on the same page when it comes to the ultimate goal of preventing severe infections in the population. The other benefit of having such technology that allows you to produce a vaccine quickly is the fact that it also responds quicker to variants. And so as variants arise, you're able to then you're able to code the new proteins or targeted protein very quickly and produce the vaccine. So this is ultimately where we want to go. The downside is that you may not receive 100% immune protection, and ultimately, with the previous forms of methods of producing vaccines, we never produced 100% protection. You were always likely to somehow get sick because of the instability of viruses and the lack of control of how someone's body is going to respond to a virus. Not everybody's body are the same. Our biochemistries are not the same. Our environmental exposures are not the same. And so it never intended to be 100% protective. The goal of the mRNA vaccine was to minimize serious outcomes. And so that should not be co-opted to make people feel that the point of the vaccine was to prevent all spread of the virus, which ultimately you hope that you have some reduction, but it was known that it would likely not be able to do that. There is no known technology that's able to do so. And so you will get some individuals, especially as new strains develop, that will have some type of illness. But the ultimate outcome is, as you had the Delta variant, for example, and the Omicron variant from the COVID vaccine, you saw that individuals who had been immunized were better able to handle those changes in variation, even without additional doses of a booster. Okay, so now let's get into the fact that most of y'all think that messenger RNA is a new technology, and it ain't. Let's talk a little bit about the history of messenger RNA technology. So, messenger RNA was first discovered in the 1960s, and it was about the 1980s when a scientist from California discovered that perhaps it can be used as a delivery, as a medication, as a drug, right? And from there became the effort to utilize it potentially as a form of immunization. So it was in the 1990s where scientists began sort of exploring the capability of developing a messenger RNA vaccine, specifically focused on the influenza virus, and they started to test it on mice. In the early 2010s is when you started to see a lot of the clinical trials evolve when it came to evaluating the efficacy of these vaccines and the safety of these vaccines in human beings. Now, the gap between the 1990s and the early 2010s is because one of the issues, or the main issue with the use of the vaccine, is the fact that the vaccine, the messenger RNA, was so rapidly degraded by the body that they had to develop a way in which to make it sustainable long enough for the human body to be able to develop and receive the instructions to develop the protein. So to develop within that time period, the use of nanoparticles in being able to sustain the longevity of the messenger RNA vaccines once it was injected into the human body. And those are basically lipid molecules that helps to protect it from the body degrading it too rapidly. And so once that technology was secured and developed and adequately effective in doing so, then the clinical trials began. And once the nanotechnology was proven to be effective, the actual first vaccine that was used via messenger RNA technology was the vaccine for Ebola. But because the outbreaks of Ebola, for the most part, have been limited, there was no use for commercial development of the vaccine until the pandemic. So the pandemic propelled what was already known and effective technology into being commercially developed in mass amounts because of the need to be able to protect the population. And you should know that this technology is not only being used to look at the ability to combat a pandemic with the SARS virus, ultimately creating the COVID-19 vaccine, but it's also been looked at in terms of preventing other types of viral infections. There is a potential for the use of this technology to combat not just infections, viruses and bacteria, but also to combat diseases. So there is a great potential use of this technology for protein replacement, for gene editing, for cell therapy, which means targeting a particular cell so that you're able to combat or attack a disease. And of course, we're most familiar with its use in vaccines. But did you know that there are other infections that the technology is being studied to potentially combat? And this includes important infections such as Zika. Don't forget about Zika, it still does exist. Zika, rabies, CMV, as well as HIV. This can be a potential game changer if we are really potentially targeting the ability to be able to eliminate HIV in the entire world. So defunding the science, the research and development of this particular technology has extreme consequences. Now, one of the things that we have to pretty much accept because there's no going back is the fact that we're now a global society, which means what happens in one country, as we learned from the pandemic, can easily impact another country. And it's really hard to completely isolate a country, right? So decreasing the technology or halting research and development using the messenger RNA technology can really affect America's ability to be a leader in this particular area of science and research in the entire world. It pretty much dethrones America from being the leader and allows for other nations to move forward in their capability of leading this particular effort, which means potentially if there is another pandemic, they are more likely to be able to be more prepared to combat the pandemic, which means it leaves America vulnerable to being dependent on the development and the expense of relying on another country's science and research. Many countries naturally and routinely share scientific information, especially when there is a global goal, which is to combat the spread of a very virulent virus or bacterial infection. Taking us out of that conversation limits our ability to be able to be prepared in the event that another pandemic occurs, especially in our lifetime. And science have predicted that it's very likely that another pandemic will occur in a much shorter time frame. We also potentially halt the capabilities of lower income countries to be able to combat the spread of virulent viruses. And as I mentioned, the more a virus infects a host, meaning a human, the more, or animal, the more it's able to spread rapidly. And as we saw with the bird flu, thankfully things are much better controlled, but we could have combat that even better had the science been ready to address it. Now, as you saw, even though there wasn't significant impact in the human public health aspect, it did impact us significantly economically. The prices of egg rose and that became a factor in people's political decision making. So that definitely shows you that research has significant economic impact. And so if a low income country is not able to combat a virus and there is still global migration of individuals, that can become an issue for all countries. So even if you don't believe in the humanitarian goal of just helping your neighbor, you should realize that not helping your neighbor can ultimately have a significant impact on your health. And that is something, if nothing else, we learned during the pandemic. The fewer individuals who get immunized against a potential infection, we know that it impacts the herd immunity. Our recent spread of the measles virus in America is as a result of a lowered herd immunity. The fewer people immunized, the more likely you will have a spread of an ultimately, potentially very controlled and previously controlled infection. There's also potential for the use of messenger RNA technology in combating cancer. And this is definitely an area of science we all want to see developed and progress. And so cancer immunotherapy, genetic disorders, autoimmune conditions are all potential areas of science and health that can benefit significantly from the continued advancement of messenger RNA technology. So is messenger RNA technology perfect? Absolutely not. But our hope is with continued research and development, we're able to perfect it to the best of our ability scientifically to minimize its potential risk. Are there risks to taking a messenger RNA vaccine like any other vaccine? Absolutely, yes. There are potentially risks. Overall, however, what we have noticed is that individuals who were immunized with the vaccine, and you can check a lot of the registries to look at the information yourself, had really mild side effects and very short-lived side effects. And so it's very well tolerated in general. There were some outcomes that warrant further research and development. So the question about whether or not it causes myocarditis is really important because that really had a significant impact, especially on young men. So it's important to be able to have the funding to really assess whether or not this is a true causation. We know that there's an association, but we don't know if there's a causation. And that means the ability to do continued studying of the population to determine whether or not there were other factors that resulted in that particular outcome in a select group within the population. The other thing to make clear that has been an area of confusion is that messenger RNA vaccines do not enter the nucleus of the cell. And why that's important is so that individuals understand that if the vaccine components are not entering the nucleus of the cell, then they are not interacting with your DNA. They're not altering your DNA. They're not changing your DNA in any way. And they're not at all encountering your DNA to be able to do so. And so it's very important that individuals understand the messenger RNA is not entering the nucleus of the cell. The nucleus of the cell is where your DNA is stored primarily. Okay? My goal today was not to convince you to take a vaccine or not take a vaccine. It's basically to lay out the risk and benefits of the messenger RNA technology and the importance of this technology in not just combating infections, but also in potentially combating really important diseases that impact a significant portion of our population. I hope that I have cleared up some of the misconceptions and dispel a lot of myths. And that being said, being able to allow you the information needed so that you can make the decisions that are right for your family, especially when it comes to the administration of the vaccine and potentially other potential treatments that would evolve in the future. My hope is that this halt will be reconsidered, and if not, that we create or maintain healthy relationships with other countries and support their research so that we can all benefit from this incredible technology. It again is not new technology. It is just newly being used as a result of the pandemic for the consumer development of a vaccination against a particular virus that has potential to be used in so many other ways. I thank you guys for watching. This is Dr. T, the hand behind the handle of Healthy Bump Club right here on YouTube and Healthy Bump Club on Instagram. I thank you guys for hanging out with me today, and I hope that I've been able to help you to have better understanding of some of the most critical topics and viral trending topics as they occur real time. Thank you guys for hanging out with me today, and I hope to see you guys when the next episode. And I'll see y'all. This is Dr. T. Just a friendly reminder, don't forget to comment, like, and share. And go ahead, why not? Click that subscribe button. Help us to get to the next 1,000 subscribers. We thank you guys for supporting.